Sorry it took a while. Welcome back. Hopefully you got a lot of gobble gobble. And yeah, let's get into it. Okay, note 19, analysis of functions. So this is one of 2 days. So maybe tomorrow we'll probably do another lesson, guys, that we can get this all out of the way. So intervals where the function is increasing or decreasing. I think you guys know what's up when it comes to all that. All this right here. Oh, sorry. That I was like, what's going on? I was about to tell you guys to. Okay, all that right here, this right here, all that just means, in case you don't understand, F is called increasing, blah, 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 open or close, blah, blah. All that just means you read a graph left to right. Read a graph left to right. Just like when you read. Does that make sense? So, if the graph is going up, left to right, you are increasing. If the graph is going down, left to right, you are decreasing. That's all that means. So in case you're like, oh my God, I don't know what all that means. That's all it means. Extrema, the word extrema, when you see it, it's Latin. I'm not a Latin expert, but it's Latin. And it just means to find your maxes and mins. Sometimes they're local, sometimes they're absolute. And it really means exactly what you hear. If it's local, that means in the vicinity. If it's absolute, that means it's the biggest everywhere. And the extreme value theorem, it's been mentioned before in the free response. I think I need to do a better job. So here's me doing the quote unquote a better job. If the function has a if F is continuous on a closed interval, if it's a closed interval between A and B, A is some number, B is some number, you have an extrema, you have a max, you have a min. Even a horizontal line. There's my axis, here's A, here's B, even a horizontal line. If it's a closed interval, every single point on that horizontal line is both a max and a min. Cool or not cool? So if it's a closed interval, regardless of differentiability, if it's closed interval and you're continuous, because it could be like an absolute value, right? Where it has a V, you have a max and a min. Cool, guys? Simple, right? Okay. So it's let's draw some extreme. Okay, so yeah, let's draw some cases. So look, closed interval, here's A and here's B. Because I have a closed interval, this point B is a max, this point A is a min. Max, min. Let's see, another situation. I'm going to write A, open interval, B. This would be a max, but do I have a min? No min. It's not guaranteed. By the way, you can have a min if it looks like this. I'm going to do open, open, open. So do I have a min? Yes, I do. Your min is right here. All the extreme value theorem says is if you, so if it would have done this, this has no min and no max. All the extreme value theorem says is that if you're continuous in a closed interval, you have a max and a min. If you're not continuous or you have an open interval, that does not mean that you do not have a max or min. Maybe you do, maybe you don't. Like this situation. This situation is not closed. See? A and B are not closed. It's not a closed interval. But between A and B, you are continuous. Well, continuous like this. Not with a bracket. And it just so happens that you have a minimum right there at the lowest point. Nothing crazy. We haven't done anything crazy, right? Okay. All right. The word local. Sometimes they use the word local. Sometimes they use the word relative. Local and relative are the same. Local min-max, relative min-max. Relative like your uncle, your aunt, whatever. The word absolute. Sometimes they use the word global. Global and absolute are the same. Absolute or global means it's the highest from all the points or it's the lowest from all the points. That's all it means. Cool or not cool? All right, and then so let's chat about the difference between local and observe the behavior of f prime. Okay, so let's see if we can figure this out. Between A, I'm going to say that A is closed, and I'm going to say that B is closed. Between A and X1, I want you to notice, is this graph increasing or decreasing? Increasing. So I'm going to write right here, I'm going to say f is increasing. And what do you notice about the derivative, f prime? Is f prime always positive or always negative? Yeah, all those tangent slopes are positive. So I'm going to write f prime is positive. And I'm going to change colors. If you have a colored pencil, look at this right here in sky blue. F is, what do you notice about the sky blue? Decreasing. What do you notice about f prime? F prime is negative. This is how you say positive. This is how you say negative. I guess I didn't write how I say positive. F prime is greater than 0. This is how you say f prime is positive. F prime is positive. And this is how you say f prime is negative. F prime is negative. Nothing crazy, right? Okay, so I'm going to go back to red. Oh, I guess I got to be careful with, well, it doesn't really look like a vertical tangent, so we're good. So everything here in red, F is increasing. F prime is positive. And of course, that is also f prime is increasing and f prime is positive. Was there a sign change? I guess I should also mention, I'm going to burnt orange. At x3, f prime is 0 because you have a horizontal tangent. Do you see that, guys? Yeah, so I'm not including the point x3. I'm just saying f prime is positive only on the open intervals between x3 and x4. Cool or not cool? Okay. Notice that at x4, you see how I have a corner or a cusp at x4? So at x4, f prime of x4 is undefined. And then I have f prime being negative, so sky blue. So there, f prime is negative. We're still okay? Nothing crazy, right? Between x5 and x6, that f prime is positive. And then right at x6, I have a vertical tangent, so f prime of x to the, or x6 is also undefined. And then again, I continue to increase. There is something about concavity. We'll talk about that later. F prime is positive again. Cool or not cool? All right. Nothing crazy, right? Okay. I want you to notice. All right. Don't worry, guys. We'll be okay. At x1, is that a max, min, or neither? At x1. Is x1 a max, min, or neither at x1? It's a max. It's the highest point in the vicinity. Do you guys see that? So this is a local max. Everything's a local, really. So that's a local max. Look at x2. Is x2 a max, min, or neither? It's a min. So it's a local min. What about, is it the smallest min on the whole graph from A to B? So it's also, I can also say it's a perfect. You can say global or you can say what other word? Absolute min. You have like a play or something? Or? Okay, if you're going to Highlands, go ahead, but make sure to watch the video, guys. Okay, at x3. X3 is x3 a max, min, or neither? The slope is 0, but is it a max, min? It's neither or neither. How do you pronounce that? Neither or neither? Neither. Yeah, it's not a max or a min in the vicinity. Like, look around you. There's points that are higher and there's points that are lower. Does that make sense? You're always increasing, except for at x3, you have a moment where it's 0, where the derivative is 0. What about x4? That is definitely it's for sure. All maxes and mins are local max. But just like Lavelle said, this is also a global max, because it's the biggest one in there. Does that make sense? What about x5? A local min? Is it a global min? No, because we have one that's way smaller than that. And is x6 anything? Nope, neither. Okay, and then there's a lot of controversy in the calculus world between endpoints. They always say, can endpoints be max or mins? Can they be absolute? Can they be local? There's always arguments. If it's a closed interval, endpoints can absolutely be global and local, in my opinion. Don't worry, the AP exam, we're not going to try and trick you. They will. You're going to hear me say this all the time, because the AP exam will do this. Find me the absolute max on the interval. It's possible that an endpoint can be an absolute max. That is always possible. The local one is the one where they have fights all the time. So look at letter B, at B. This is a local max, because it's the biggest one in the vicinity. And it's not, is it a global? No, because it looks like x4 is bigger than that. And let's go back to letter A, because I didn't classify letter A. Letter A is a local what? Local min. Does that make sense? Yeah, and there it is. That's it. I think we've put as much stuff as we can for each one, and hopefully we observed something. What did we observe? Well, we're gonna write what we observed in a little bit. You don't have to read all this. I typed this out. This is how we find max and mins. It's very easy to be a robot. Try really hard to not be a robot. Try. Critical point. A critical point is like where something's happening. Sometimes it's a max, sometimes it's a min, sometimes it's neither, just like these. So all these, x1, x2, x3, x4, x5, all those are critical points. So I'm going to write x1, x2, x3, x4, x5, x6, all those are critical points. Chav, what are you talking about, critical point? Here's what I'm talking about. This right here. It's wherever the derivative is what or what? Or does not exist, undefined. Cool or not cool? Cool? All right, here we go. And then relax. This just means, look, it says increasing or decreasing. F prime is greater than 0 at each point on A to B. Notice that A to B has a parenthesis and not a bracket. Then F prime increases on A to B. If F prime is less than 0 at each point between A and B, then F decreases on A to B. So what did that mean? All that means is, guys, if the slope is positive, if your derivative is positive, F has to be increasing. If your derivative is negative, F has to be decreasing. And that makes sense, because remember that F prime means slope. So if F prime is positive, F is increasing. If F prime is negative, F is decreasing. Cool or not cool? Cool. Yeah, that's all it means, guys. So the first derivative test. So here we go. We're going to draw some stuff. Relax. I'm going to draw points A and B. So I'm going to draw, here's my grid. I'm going to say here's point A, here's point B. And I guess it says F prime changes from positive to negative. So for now, I'm going to make it all closed. So closed. I don't have to make it the same length or the same. All right. F prime changes from positive to negative. Do you see how at C here, F prime is changing from positive to negative? Right at C, F prime of C is 0. And I want you to notice that on this interval between A and C, F prime is positive on parenthesis A to C, and F prime is negative on C to B. Do we notice that, guys? It doesn't have to look like that. It does not have to look like that. Look, here's the same shebang. A, B. Look what I'm going to draw. I'm going to draw and look at, and that's still closed. Not that it has to. Look, the same still applies. Between A, I'm going to call this F. This is F, F, and F. Notice that the derivative is positive between A and C, and the derivative is negative between C and B. Are we okay? So from now on, here's what we're going to say. You have a max if the derivative changes from what to what? Perfect. Write that down. I'm going to say F has a max if F prime changes from positive to negative at C, at X equals C. F has a max, I guess I should be specific. F has a max at X equals C if F prime changes from positive to negative at X equals C. And I know it sounds funny because we're saying X equals C twice. F has a max, that's a caret for insert, right? Just like in English. F has a max at X equals C if F prime changes from positive to negative at X equals C. That's called the first derivative test. If the derivative changes from positive to negative, F has a what? Max. Say it with me. If F prime changes from positive to negative, F has a max. Okay, let's do it one more time. If F prime changes from positive to negative, F has a max. And we got to be specific. I already know. Look, I'm telling you right now in advance. Some of you guys are going to tell me it, the word it. It has a max. What is it? Do not use the word it. Be specific. F has a max. F has a min. F prime changes from positive to negative at X equals C. Hence, F has a max at X equals C. Does that make sense? Perfect. Yay, hallelujah. Let's go to the next one. Number 2. F prime changes from negative to positive at X equals C. All right, let's draw something that does that. So I'm going to go and I'm going to put, here's my grid. And we're going to do first where the derivative is 0. So I'm going to say, here's point A, here's point B. Make enough room for two of them. So here's my first F. Let's see. Oh, no, it's too low. It says negative to positive, so I'm going to make it up here and down here. All right, here it is. Negative to positive. There it is. And I'm going to call this point here, I'm going to call that point C. And let's do another one. So another grid. And the same thing's going to happen. This time I want to make, this one I'm going to do linear lines. Linear line there. A. Doesn't have to be perfect. B. C. Okay. The one on the left here, F prime of C equals 0. That's a critical point. The one on the right here, F prime of C is, you can say undefined or you can say does not exist. Does that make sense? Nothing crazy, right? But what do we notice? F prime is negative. Oh, did I mess up somewhere? F prime is negative on the interval A to C, and F prime is positive on the interval C to B. And that is true for both of them. Do you notice that? So we're going to say, here's a statement we're going to say. I'm going to write it up here because there's space here. I'm going to write F has a min at X equals C if F prime changes from what to what? Changes from, perfect guys, negative to positive, where? at x equals c. And I know it sounds funny saying it again, but say it again. F has a min at x equals c if f prime changes from negative to positive at x equals c. Yeah, f has a min at x equals c if f prime changes from negative to positive at x equals c. Cool? Yeah, I know in the last one, I think, well, maybe, no, we did say it. X equals c, we inserted it. Okay, f prime does not change signs. That's a simple one. I like this one. I'm going to do again two graphs. And I'm going to say this is A. I'm going to say this is B. We'll make one increasing without the sign changing ever. Or we'll make it where it's 0 for a moment. And then we'll do one where it does not exist. Let's see. We'll do B, A, on this one, f prime of c does not exist, D and E. And on this one, f prime of c equals 0. This is a graph of f. I did say that on. Anything crazy so far, guys? Okay, I want you to notice the one on the left. So here, let's split down the middle. So f prime is positive on A to C and on C to B. Do you guys notice that? So, is there a sign change? Nope. No sign. Well, f prime does not have a sign change. No sign change on f prime. Same thing with the right, but with the right on this one, I'm going to write this one in sky blue. F prime is negative on A to C and C to B. Is there a sign change again? Nope. So no sign change on F. No sign change on F prime. How do we feel? Nothing crazy, right? It needs to change signs at x equals c. And I guess I should be specific. At x equals c. And same thing with the other one. At x equals c. Nothing crazy, guys? Okay. And then here's where we talk about the left at point, assuming that you're continuous. So here it is. Here's the grid, and I'm going to call this point A. And notice it says if f prime is less than 0. So here's A, and I'm going to go, and then here's B. I want you to notice that A is a max. See? F prime is less than 0. F is negative on AB, comma, f of A is max. Or I guess, you know what, I haven't been using that notation. F has a max, because I want to stay consistent. F has a max at x equals A. All right, and I'm gonna explain. Think about it, guys. I know it's hard after coming back from a whole week off, but think about it. If you have a function that's always negative, the derivative is always negative, then your endpoint has to be a max, because you start, and then as soon as you start going downhill immediately. So if you start going downhill immediately, then wherever you started has to be a max. Does that make sense? Perfect. Look at number 2. So I have a grid, and as soon as I start at point A, my derivative is always positive. So that means f is what? Well, yeah, but f is always, if my derivative is always positive, f is increasing. So if you start right off the bat and you start going uphill immediately, then wherever you started has to be a min. It has to. So here's another one. Point. Here I'm going to say that's A, and I start increasing right off. I'm going to start increasing right off the bat. So there I am, increasing right off the bat. So because I started increasing, I'm going to write f prime is positive on a comma b, and then comma f has a min at x equals a. Is this making sense, guys? Okay, let's go to, it's the same idea, guys, at the right endpoint at b. So, and we're assuming that all these functions are continuous. So just draw. Maybe by now you're already pretty good and you can already figure this out.
Teachers and students, please pardon interruption. This is just a test. This is just a test. Please pardon interruption.
Yeah. Okay, sorry. All right, it says f prime is negative. So if f prime is negative, that means I'm what? Decreasing. F is decreasing. So here it is. Here's a graph decreasing. It doesn't matter the concavity for now. You can decrease concave up or decrease concave down. It doesn't matter for now. So we're going to say, there it is. My f prime is decreasing. So I'm going to write f prime is negative on AB. And then notice that at B, this is f has a min at x equals b. Do we notice that, guys? That's because you're ending at b. So if you keep going down, you end at b. All right, and then if you keep going up and you end at b, so here's a, here's b. See, I did concave up. I did concave up, so now I'm going to do concave down. A and b. So f is positive on AB. F has a what? At B. F has a max at x equals b. How do you feel? Nothing crazy, right? Okay. So let's do an example. This is actually one that we see on UH, and it's not a very good example. I probably should not have put it in there immediately, but that's fine. I think this one is easy enough that we probably should do it by hand, because I think you guys are visual. So we're going to go slow. We're going to go slow. Cool? Be happy, guys. Be happy. What would you rather be doing, this, or would you rather be at home? Don't. Guys, we're learning. Or maybe it's me. Okay, let me make it more entertaining if I can. All right. So look, this is F. Yeah, I didn't bring any cookies. Sorry, guys. Maybe tomorrow. We'll see. So no, you know what? I take it back. We'll see. We'll see what the future holds. So look, guys. So I have 3x here. If I plug in a 0, what's 3 times 0? So there it is, 0. And then I know it says open. It has an open for 1. But so I'm going to do an open circle. What is 3 times negative 1? Oh, negative 3 times 1. Sorry, negative 3. So here's 1, and it's not to scale. I'm going to say 1's right here. It is not to scale. Here is negative 3. I hope I don't go lower than that. Boom. And that's how it looks for that first one. And then between 1 and 5, I look like x minus 4. They're all linear lines. So if I plug in a 1 in there, 1 minus 4 is negative 3. So I'm going to continue there. And I'm going to fill it in. And what's 5? 5 minus 4 is... So I'm going to put 5, and I'm going to put a 1 here. That's 1. And that's a closed circle, and the other one's a closed circle as well. And I just connect them. See? So let me show you let me color code it. This one I'm doing it in red. This one I'm doing it in sky blue. And then let's use purple. I'm using that one for purple. So if I put a 5 in there, 6 minus 5 is 1. And if I put a 9, 6 minus 9, that's negative 3 again. So I'm going to go to negative 3. That's the lowest I go, and I connect them. So here's how it looks. Cool. F of 0 is an endpoint, and F of 9 is an endpoint. So this is 9. Not to scale. Not to scale. Not to scale. Okay. I have critical numbers where?
That vertical circle is open on the 5, right?
Yeah, but it doesn't matter because it's closed on the 5 for the sky blue. Yeah, it's closed. It's closed because it's closed on the sky blue one, and it's closed because it's closed on the sky blue one as well. And it just so happens that the y values are the same between 0 and 1 and between 1 and 5. And then the y values are the same again between 5, 1 and 5, and between 5 and 9, the expressions. Cool or not cool? Yeah, okay. Not to scale, and I want you to notice that I have critical numbers f of 1 and f of 5. The derivative is undefined, so that means those are critical numbers. So I'm going to write f prime of 1 and f prime of 5 are both undefined, comma, hence critical numbers at x equals 1 and 5. X equals 1 comma 5. Cool or not cool? All right. Remember that what's a critical number? Wherever the derivative is what or what? Undefined or 0. And you're undefined at 1 and 5 because those are corners. Yay or nay? All right. Let's just go through the answer choices, guys. Critical number at x equals 1. Local and absolute min at f of 1. Local min at f of 0. Okay. Why is letter A wrong? Well, yeah, two. I guess you could also say that, but it doesn't say necessarily that I have to have 2. It just says critical number at x equals 1. But you're right. This is why it's 100% wrong. It tells me that f of 0 is a min. Look at f of 0. That's an endpoint. Is that a min or is that a max? It's
Oh, wait, sorry.
yeah, it's a max. Do you guys see that? So letter A is out because of that. The main, and maybe you can make a point for, well, it only says there's one critical number. And you're right, there is 2 critical numbers. Let's see what letter B says. No critical numbers. Is that true? Out. Letter C, critical number at 1 and 5. Okay, so far it's looking good. Local and absolute min f of 1 equals -3. Local max f of 5 equals 1. Absolute min f of 9 equals -3. Maybe I would have liked it to say that both f of 9 and f of 1 are absolute mins because both of those are at -3. Do you know what I mean? So let's see what letter D says. Let's see if letter D says both. Critical number at 1 and 5. So far looks good. There it is. Local and absolute min. Oh, it does say absolute min on the top one. Local and absolute min f of 1 equals -3. Okay, check mark. Local and absolute max f of 5 equals 1. That's better. Absolute min f of 9 equals -3. Yep, letter D is the best answer. I kind of feel like this is kind of a trick. Because f of 5, local max, f of 5 technically is a local max. But is there a better answer? Well, f of 5 is a local max, but it's also a absolute. Yeah, it's a global. Cool or not cool? Yeah, I kind of don't like this question, but sorry, I just got it from UH. That's how it came. Okay. All right. Don't worry, guys. We're almost done. We just have a few left. Not so far. For what values of x does a function have a relative maximum? All we know right now is first derivative test. First der test. That's all we know. So I find critical numbers. So step 1, because I'm listening to you guys. Find critical numbers. Are we still okay? All right, so let's find the critical numbers. So I find the critical numbers by finding the derivative and equal it to what? 0 or undefined. We're going to set it equal to 0. So f prime of x equals first x minus 2 times the root of the second 2 parenthesis x minus 3 times 1, so there it is, plus second x minus 3 squared times the root of the first, 1. Are we okay? We're okay, guys? Nothing crazy, right? Okay, can we do that without a calculator and without any help from any apps? Okay. Now I'm going to do algebra. I group and I group. Notice that I can factor out an x minus 3. There's one x minus 3 on this one. There's an x minus 3. There's 2 of them on that one. Do you guys notice that? So here it is. X minus 3, factor it out. Big parenthesis. Set another parenthesis. I'm going to go ahead and distribute that 2 like that. Do you guys see that? So I have 2x minus 4, and I still have a 1x minus 3 left, plus x minus 3. Have I confused anyone? F prime of x equals, let's see, x minus 3, close, open. What's 2x plus x? 3x. Negative 4 minus 3? Minus 7. Are we still all right? I'm going to equal this to 0. I'm finding critical numbers. X equals 3. X equals 7/3. Now don't, I know some of you guys see the 7/3 and immediately want to circle. Don't do that yet. Are we still okay? I'm going to do a railroad track. When a professor calls you, this is railroad tracks, right? These are my critical numbers, right? So I go F prime and I put a little hash, what is it called? Little tick mark. And by the way, 7/3, that's a number slightly bigger than 2. So it looks like that. Doesn't have to be perfect. Are we still okay? Okay, all you care about is the sign value. You don't care about the actual number of output. You okay, Delgado? I know you guys are tired because you guys have probably really bad sleeping habits and you're probably running on very little sleep. Okay, you guys ready? I'm going to plug in a value to the left of 7/3. Give me any number. Any number. 2 or 1 or 0. I would have chosen like 0, but okay, 2. 2 minus 3, positive or negative? Negative. You just care about positive or negative. You guys said 2, right? 3 times 2 is 6. 6 minus 7, positive or negative? Negative times a negative? Put a plus symbol. Give me a number between 7/3 and 3. 2.5, because 7/3 is like 2.3, right? If I plug in a 2.5 in here into the x minus 3, you get a negative. If I plug in a 2.5 into this guy, 3 times 2.5, you get a number a little bit bigger than 7. Right? Because 3 times 2 is 6. So 3 times 2.5 is going to be a little bit bigger than 7, because 3 times 3 is 9. So negative times a positive is a negative. Give me a number larger than 3. 4. 4 minus 3? Positive. 3 times 4? 12 minus 7, positive or negative? Positive times a positive? Positive. They want a relative min. I have a min when the derivative goes from what to what? Positive to negative or? Negative to positive. So where do I have a min at? I don't have an E. Did I mess up?
I think it's supposed to be a maximum.
Oh, it says relative max. Man, why come you guys didn't tell me that I don't know how to read? Maximum. But why do man, hold on. That one says negative 3. Did I mess up somewhere?
It says maximum.
Yeah, no, but.
You can have a min.
Oh, maximum. I'm still in my Lulu land. Okay, maximum. So where the derivative changes from what to what?
Positive.
Positive to negative. So where did the derivative change from positive to negative? Yeah, I'm sorry, guys. Do we get it though? Okay. Don't worry, we're almost done. We got a few more. Find the intervals where this is increasing. So I give you guys an easy one to take a derivative. So we find what? Find critical numbers. So here we go. F prime of x equals, what's the derivative of 7x to the 4th? What's the derivative of 4x cubed? Perfect. I set the sucker equal to 0. Undefined, 0 undefined, but in this case it is 0. I'm going to factor out, does 12 go into 28? No, but 6 does. 6 parentheses, how many times does 6 go into 28? Oh wait, it doesn't. 4 goes into 28. How many times does 4 go into 28? 7x, oh, and we're also factoring out an x squared. 4x squared, sorry guys, not my A game. All right, 4 goes into 28 7 times, so 7x plus 4 goes into 12 3 times. So I have a critical number at 0 and a critical number at negative 3/7. Are we okay? I do a railroad track. I'm going to call this F prime. I'm going to put a tick mark at negative 3/7 and a tick mark at 0. I pick a number to the left of negative 3/7, any number. -1 or -10, whatever number you think is easiest. -1. You okay, Espinosa? So if I put a -1 in here, negative number squared, it's going to turn into a positive. So if you want, you don't even have to look at that because that's always going to be plus. 7 times -1 is -7. -7 plus 3 is negative. So put a negative number there. A number between negative 3/7 and 0, well, like -1/7, right? There's like a -1/7 somewhere in here. And if I put a -1/7, you don't care about the 4x squared because that's always going to be positive. 7 times -1/7, that's just -1. -1 plus 3, so that's going to be a plus. Do you guys see that? And a number bigger than 7/3, or than 0, sorry, like 1, that's always going to be a positive again. Cool or not cool? So where are you increasing? I guess technically, okay, I guess we should talk about this. F prime is positive between negative 3/7 and 0. And is there a sign change at 0? No, between 0 and infinity. So where are you increasing? Yes, that's what I was about to say. F is increasing from, because it's continuous, from negative 3/7 all the way to infinity. Does that make sense, guys? Good job, miss. Okay. 2 more, and then we'll have a second iteration of this tomorrow. Find the intervals in which this function is increasing. So find critical. Don't worry, we're almost done. Find f prime. So here we go. F prime of x. Bottom times right over the top. Plus or minus? Minus top times right over the bottom, which is all over. Perfect. This derivative, it is not possible for it to be undefined because you'll never get a 0 in the denominator. So you just set it equal to 0. The only way this will equal 0 is if the numerator equals 0. Does that make sense? So we're just going to do some algebra. And it's not hard algebra. Let me see. I can see that I can factor out a 6. So maybe don't distribute the 6 there. Put a 6 like that. And then I see x squared plus 49. Let's see, minus 2x squared. Do you guys see that? And so let's see. So 6 parentheses negative x squared. Plus, oh, I don't care about it. Why do I not care about it? It will never be undefined. Because I'm squaring the x value and I put plus 49. I'll never have a 0 in the denominator. So the only way this will ever be 0 is if the numerator is 0. That's what I said before I started just writing the numerator. Yeah. So I get 2 values. Does everyone see how I got plus or minus 7? Okay. 7 squared is 49. I have a negative in the front. Negative 49 plus 49 is 0. Negative 7 squared is a positive 49 again, but I still have a negative in the front, so negative 49 plus 49 is 0. Yay or nay? Perfect. I do a number line. I go negative 7 and 7. This is for f prime. And I check where my derivative is positive because I want to know where f is increasing. So I choose like negative 10. And I'm going to plug, I don't care about the denominator. The denominator is always going to be positive. I'm just going to plug it into this guy. If that is positive, then it's increasing. If that's negative, then it's decreasing. Right? Okay. If I plug a negative 10, negative 10 squared is 100, but I have a negative there. Negative 100 plus 49, positive or negative? Yeah, negative, sorry. I'm going to plug in a number like 0, because that's the easiest one between negative 7 and 7. 0 squared is 0 plus 49, that is. And then I'll plug a number like a 10. 10 squared is 100, but I have a negative in front. Negative 100 plus 49, that is. Where am I increasing? Negative 7 to 7, right? I don't know. Yes, Ms. Cortez. Yes. So I'm increasing between negative 7 and 7. So here's how you write it. F is increasing on the interval interval. And I guess we can put, negative 7 comma to 7, since f prime is positive on negative 7 to 7. Notice that I put f prime as positive on the open interval, but I'm increasing on the closed interval. Just make an observation of that. Let me take attendance, take a 30-second break. What time did you guys go to sleep today?
Last night?
No, today, because some of you didn't fall asleep till like 2 or 3 in the morning.
3 and 40. Jennifer.
Yeah, when you have like a week long, everyone's sleeping habits goes away.
Bro, I went to sleep at 8 last night. I get calmed out so fast.
That's because you have a job, so you probably were working, so you maintained your normal sleeping habits.
Busy.
But if you don't have a job and you're just like you can do whatever you want when you want, yeah, no,
Girl, I always I do it during shows. I'm like, doing tycoons or doing stuff to grow my kids or stuff.
Steal candy from babies to save your dog. Love that one. It's so boring.
AFK in the games, and then I watch my show.
All right, here we go, guys. Last question, last one, and then we're set free. It wants to know where f prime is 0, where f prime is positive, and where f prime is negative. Put arrows on this. All right, tell me where f prime is 0.
At -1.
At -1 and positive 1. Do you guys see that? So I'm going to write f prime of -1 equals 0 and f prime at 1 equals 0. And I'm going to put for good notes, I'm going to say we have horizontal tangents at those values. We have horizontal tangents at x equals plus minus 1. All right, tell me where f prime is positive. Nope. There's an arrow here.
Oh, so it's -infinity.
All right. F prime is positive on interval -infinity to -1 parenthesis and 1 to infinity, period. Tell me where f prime is negative. Yep. So there's one bullet right there. Here's my second bullet. I'm going to put it in sky blue. You know what? I'll even color code it. Positive there, positive here, and then I'll use purple. You guys like colors, right? Bullet. F prime is negative on interval -1 comma to 1. That's all they wanted. They wanted to know where it's positive, negative, and 0. How do we feel? Do you feel good about today? Okay, I didn't put any deltas. What I recommend, guys, is maybe work on some of your reviews or something. I will print out a review packet for you guys to start reviewing for your semester exam. Your last exam for the 3 weeks besides the semester exam is something on UH called Test 1. Derivatives. You know 75% of it, 80%. The only thing you're missing is this that we did today and concavity. As soon as you learn concavity, you will know 100% of that test. I recommend you start taking it now, that way you can start asking me questions on what we don't know. Does that make sense? And then the concavity stuff, all that you see on there, we're going to learn it this week. So by the end of the week, you should be able to knock that test out. Cool or not cool? All right, guys, tomorrow we're not going to do, usually you know how we have like an activity or something. Tomorrow we're just going to continue this. So it's going to be notes 2 of 2. And then by Wednesday we'll give you time to work on stuff. Is that cool with you guys? All right, we're done, guys. Was today's notes good or no? Should I upload this one? Do you guys want to say something to Angie?
I miss you. I miss Angie. I hope she feels better.
All right.
Angie's always sick. I hope she feels better. Bye.
Everyone's wishing you the best. Everyone wants you to recover. So hopefully, yeah.
Speedy recovery.
They said you're the real MVP.
Real MVP, Angie. Yeah.
You're the GOAT.
Yeah. That's important.
Okay, what else?
She's so cool. We love you.
Okay.
See you later. Bye. Christina, how many pieces are due? 9.